Hi, in this lesson, we're going to take a look at three types of machine learning. Remember that machine learning is a process of presenting a computer with input data, letting our chosen machine learning model learn from the data using a series of mathematical algorithms, testing the trained model to ensure success, then using the model to make informed decisions and insights about future inputs. There are three main types of machine learning algorithms that are most commonly used: supervised learning, unsupervised learning, and reinforcement learning. All of them still follow the general process of using training data to develop their models, but how the training and development occurs looks different for each. It's worth mentioning as well that these are three types of machine learning algorithms. Specific algorithms like linear regressions, decision trees, deep learning, or neural networks will fall into one or more of these types, depending on how they are implemented. Let's talk about each of these and explore a few examples. With supervised learning algorithms, we act as the teacher or the supervisor in the learning process. In the training data set, we provide the input data called data features, like images of cats and dogs, as well as the data labels. The labels are going to be what we want the model to be able to predict, and are ways that we, as supervisors, provide context or meaning to the data. In this example, we want the model to be able to predict if an input image is a cat or a dog. As the machine learning model is going through its training process, it learns to associate the properties of certain images with the word cat and others with the word dog. In practice, we'll probably actually use numerical labels like 0 and 1, but they serve the same purpose. When training and testing is complete, we can now send in a new image of a cat or a dog, and it will predict which one is present. Remember, the data could be anything, as long as we provide features and labels. For example, we could use a data set of Titanic passengers and build a model that would predict whether or not a passenger survives. Values in the training data set like age, sex, class, and fare would be our data features, while the values that say whether or not the passenger survived are the data labels. Once trained and tested, we can now send in a new passenger's feature data, and the model will predict whether or not the passenger will survive. Remember back to your math and science classes when you plotted data on an XY coordinate plane, then drew a line of best fit to match the data. For example, maybe looking at the relationship between force and the acceleration of a car in a physics class. These are also examples of supervised learning, where the x-axis values, the applied force in this case, are the data features, and the y-axis values, the acceleration, are the labels. The line of best fit is the model that is trained by the data. With this model in place, if we're given a new x value, we can predict what its y value will be. We're also very good at learning from our own observations of the world around us, without anyone providing us with the answers. Imagine we are given a pile of leaves and we are asked to make three groups based on their similar features. We may come up with something like this. Without being told exactly how to group them, or by what qualities, we are able to come up with three groups of leaves that more or less resemble one another. This is an example of what we call unsupervised learning. And it might help to reveal something about a particular grouping of leaves that we might not have discovered on our own. With unsupervised learning, the teacher or supervisor is not present, which means that our training dataset will have features but no labels. Here we have a selection of leaf data. We are not specifically telling the model which group each leaf belongs to during our training process. The model does the exploring on its own, looking for patterns amongst the features. Turns out computers are pretty good at this, even better than humans when there are lots of features or rows of data. Let's look at a simplified version of our leaf data. We are going to plot each leaf on our chart depending on its width and length. Then we'll use this data to train an unsupervised learning algorithm called a clustering algorithm. We'll tell it that we want three groups or clusters and let it loose to learn about the data on its own. When it's done, it has determined three clusters among the leaves that look something like this. Now these clusters may seem obvious to us for this simple example, but imagine if you have 10 different features instead of 2 and thousands of different leaves. Of course, there's no right way to cluster data either, and training the same model with slight adjustments may result in slightly different groupings. With our trained model in place, we can now use these groupings to learn more about the characteristics of each group and dig into some of the similarities and differences. Another clustering example could be using different body measurements, like for the chest, arm, wrist, forearm, neck, etc., to create groupings for shirt sizes. The last type of machine learning we'll talk about is something called reinforcement learning. At its core, reinforcement learning is simply learning to complete a task or about the world through trial and error. As humans, we've been learning this way since our earliest days on the planet. We learn to stand up, balance on our feet, and eventually to walk, all through trial and error. We didn't know all the physics details behind it, but we knew what we wanted to do, and we could feel out what actions did or did not lead to success. Many children are also given external feedback from adults, like smiles and cheers, about what were good or bad actions. All species on the planet will repeat actions that lead to rewards or success, and reduce the frequency of those that are penalized or hurt. Reinforcement learning is one of the leading ways that companies are training robots to walk and move as well. While we could, and some do, train these actions via supervised learning, sending in lots and lots of labeled data about how to move each limb correctly and building these types of data sets can prove challenging. Ultimately, supervised training limits the success of the movement by the quality of the dataset. With reinforcement learning, however, we don't need to understand all of the smallest details. We just need to know what we want the final output to resemble. As the robot begins to move in ways that align with what we want, we can provide it with rewards to continue performing those actions. Over many iterations, the algorithms learn what to do and what not to do to be successful by following those rewards. Okay, so let's do a quick summary here. Remember that machine learning is the process of presenting a computer with input data, letting our chosen machine learning model learn from the data using a series of mathematical algorithms, then using the model to make informed decisions and insights about future inputs. There are three main types of machine learning algorithms that we use, though in practice we can also use them to support each other as well. Supervised learning is the practice of using labeled data to teach the computer. Unsupervised learning is allowing the computer to explore the data on its own and come up with its own discoveries. And reinforcement learning is having the computer agent complete many trials, learning from each one based on designated rewards and penalties. Now it's your turn to see this in action.